And this is chapter 3, structured program development in C. And let me bring up previous program. There we go. And I've got rid of a lot of slides in here. I'm going to focus on very specific structures, very specific statements, and so forth. Control structures. C provides 3 types of selection structures. We got our if else, and switch. The if is a single selection, the if else is a double selection, and the switch is multiple selection. And then we also got repetition statements. We got our while, do while, and for loop. Now here's an example of an if statement. So if grade is greater than or equal to 60, then we do this printf. So for example, over here, I'm going to write a program that asks for the sales. And if the sales is greater than a certain amount, then I'll give a bonus of some sort. Okay, so sales. And I'm going to get this from the user, so I need to ask him for it. So I'll say input sales. And trying to remember which slash it is. I think it's that one. That's, well, no, I actually want to stay on the same line. Never mind. Okay. And then I want to bring in the sales. So I'll do my scanf, %lf, comma, and then the and sales. Now, let's just start off printing that. So printf %.2f and sales. I guess I can clear this up. So if I run that, okay, sales undeclared. I didn't put a semicolon on it. There you go. Sales, I put in 5,023. Comes back, tells me 5,023. When I do a printf and I don't have anything except for this format specifier in here, then it prints just that value of that variable. The percent indicates the format specifier. The F indicates that it's going to be a double, and a 0.2 means rounded 2 decimal places. Okay, now what I really want then is to check if sales is greater than 10,000. So if it's 10,000, I want to give a bonus. So I could either just print what the bonus will be, or I could put it into another variable. So I could have a bonus right here. So bonus is going to equal to $500. And then I could do a printf here. Bonus was %.2f /n, comma, bonus. Okay, now this if statement, if it's greater than 10,000, then bonus is equal to 500. But if it's not greater than 10,000, I have not initialized bonus. And so either it won't compile or it'll give us invalid results. Let's run it and see. Okay, so I'll put in $100 for sales. And bonus is 0.00. Actually, defaulted to 0. But it's good programming practice to always initialize it if you're not sure if it's going to be captured down below. So I'll come up here and I'll say bonus is equal to 0. And now if I run that, if I put 100 in, still does the same thing. But now, if they ever change C such that you have to initialize it, I'm set. Now, this is what we kind of looked at last time with the greater than, less than, and so forth. In addition to that, we'll build. You can have, and this shows a if-else selection statement. We have if something's true, then you do this, else you do this. Here's an example. If grade is greater than or equal to 60, you do this printf, else you do this. So right here, I said if sales is greater than 10,000, I'm giving a bonus 500. So down here, I could put an else bonus is equal to 100. Maybe by default, I'm giving $100 bonus no matter what. I want to encourage people. So this comes down here. Of course, it gets my sales. Then it comes down here and checks the value of sales against 10,000. This will return either true or false. If this is true, then it'll run this line of code. And then after it gets done running that line of code, it'll drop down to after this if-else structure, and it'll run this next line. Now, if this is false, so if sales is not greater than 10,000, it will not run bonus equals 500, but will come down to the else. And then it'll run this line of code. So if I run that, and let me put 200 in for sales, you see it comes back and tells you my bonus is $100. Now, since all of our possible paths cover setting bonus equal to a value, technically we would not need to set it equal to a value here. Doesn't hurt anything, but we wouldn't need to. But that's a if else. There's a conditional operator, a question colon. I don't really like this, but I'll show you an example. And maybe you don't have to. No, you don't have to have a colon. The put s statement writes something to the screen, kind of similar to the printf. But what this checks is there's like an implied if statement here. So this is saying if grade is greater than or equal to 60. And if that's true, it'll do this first part, this past. If it's not true, it'll do the second part, the failed. So it's a very concise way to do an if-else statement. If you want to use it, that's fine. You find examples in the book, go into a lot more detail. I'm going to ignore that because I don't like that structure. And you can have nested if-else. What'd you say? Oh, did you have a question, Brayley, or just? Okay. Now this is our coding that we can put in here. We can have if this, then do this, else, then do this. So let me request somebody's grade, and then I'm gonna tell them whether they got an A, B, C, D, or F. So let's see, do double grade. I'll say printf input grade. I'll do my scanf percent LF, and then and symbol grade. So at this point, they've typed in their grade. So I'm going to do an if grade is greater than or equal to 90. If it's greater than or equal to 90, then it's an A. So I'll say printf, you got an A, /n. Then I have an else statement here, else if grade is greater than or equal to 80. Printf, you got a B, /n. Else if grade is greater than or equal to 70. Printf, you got a C. Else if grade is greater than or equal to 60. Printf, you got a D. And if you didn't get any of the above, then you must have an F. So printf, you got an F, /n. Get rid of this. Well, let's talk about what happens here. Let's say the grade that you enter is 92. You might be looking at all of these and say, well, that's greater than or equal to 80, that's greater than or equal to 70, that's greater than or equal to 60. You want to print all of these, but it won't. Because the way an if structure works, it's come down here and it says if grade is greater than or equal to 90. So it's going to check this first. And since I got 92 in for my grade, 92 is greater than or equal to 90, so it'll do this printf here. And after it gets done doing that printf, it'll drop down to below the if-else structure, and next thing it'll do is this return 0. So we'll not do these other ones. Now, on the other hand, if I put in 83, comes here and checks, is 83 greater than or equal to 90? It's not, so that returns false. So then it comes down to the next else if here, and it's checking to see if 83 is greater than or equal to 80, which it is. So it'll print this, you got a B, and after it gets done printing that, it'll drop down after the if-else structure and do this return 0. So if I run this, if I put in like 73, since you got a C. If I put in 33, says you got an F. Now this doesn't have any kind of error checking in it. If I put in, I got 30,000 on the test. You got an A. Well, if the maximum points is 100, assuming, then you can't get 30,000. So no error checking, but that's how you do the if-else. And they got it so you can have it indented like this, or you can break it down into this. And you're welcome to use the printf or the putS, whichever one you'd want. Now they use a convention that when they got the if statement, they put braces around it, like that. You do not have to do that if you got a single line of code. Shut my door because I hear a vacuum. That means I'll probably come in and start vacuuming. Now, if you got 2 lines of code, you have to have braces around it. For example, if I wanted to put another message in here besides this printf, then I'd have to put a beginning curly brace there, and it puts a closing curly brace. And now I'm going to move this printf right here, move that in there, and I could have another line of code. You can have however many lines of code you want. Fantastic job. /n. Now you can have a mix of these. The rest of these, since the rest of them are single lines of code, you don't have to have braces on them. You can; they don't hurt anything. But if it's a single line of code, you don't need them. Now, if I run this, if I put 92 in, it says you got an A, and it says fantastic job. Okay. Now there's a repetition statement. Specifically, this is looking at the while. And here's an example of a while. We set product equal to 3. And we say, well, product is less than or equal to 100. We take product is equal to 3 times the product. And probably didn't make a whole lot of sense on that one. But what this is doing is it's reading in, looks like 10 grades. See how it says, while counter is less than or equal to 10? So it's reading in 10 grades. I know it's entering, asking for grades, but it says enter grade. So it's reading in 10 grades, and it looks like it's adding the grades up and then having the counter. And then it'll figure the average. So let's go ahead and implement this. I guess I can use my grade, leave my grade there, but I want average too. So let me create a new variable called average. And I need the count too, because average is equal to your total divided by your count. Now to get our total, we need another variable, total or sum, whatever you want to call it. Now, initially, I'll set count equal to 1. And I want to continue while count is less than or equal to 10. Then, down here, I'm going to increase count by 1. Now, let's talk about these different items here. When you're using a while loop, you have to have your initialization. And then what you're initializing is whatever variable you're working with here, whatever's inside your while loop, which is count. And so I set it equal to 1 initially. And then this, besides being my while, is my Boolean check. This is checking when do we stop. So we're going to continue running whatever code's inside of your curly braces here over and over while count is less than or equal to 10. So while this is true. And then you have to have your increment or arithmetic adjustment here. It doesn't have to be an increment. In this case, I'm increasing count by 1 each time. Now, just so we can see what in the world this looks like, printf %d/n, comma, count. And let me get rid of the rest of these. And if I run this, looks like it prints 1 through 10. Now, that's not what we're wanting to do, but that shows the flow of the while. So it comes down here and sets count equal to 1. It checks, is count less than or equal to 10? It is, that's true, so it comes and runs what's code inside here. This code in here just prints the current value of count, which is 1. Then this increases count by 1. So it takes the old value of count, which is 1, adds 1 to it. 1 plus 1 is 2, and assigns that to the variable count. Now then, when it hits after this line, and it hits this brace, it comes back up here and does this comparison again. It says, okay, now count as 2. Is 2 less than or equal to 10? Yes, it is. It's true. So it does this code again. Prints out 2. Then it takes the value of 2, puts it here. 2 plus 1 is 3. Assigns it to count. Hits a brace, so it comes back up here. Count is now 3, and it's saying, is count less than or equal to 10? It is. 3 is less than or equal to 10, so that's true. So then it does the code in here again. Now, it's a good idea whenever you're developing a while that you automatically put your initialization, you automatically put your Boolean check, and you automatically put your increment or arithmetic adjustment of some sort. The reason why is if I do not have this count equals count plus 1 right here, then it'll be an infinite loop because count never changes. It's always equal to 1, which is always less than or equal to 10. So it'd run forever. If I don't have the initialization, then it may initialize it something I don't want. Maybe equal to 0, maybe equal to null, depending upon the compiler. Is there any questions on how a while loop works? Okay. Well, what I really want in here is I don't want to print the count. I want to ask for a grade because I'm trying to get 10 grades. So I'm going to say print printf input next grade. And I'll say grade, or scanf, sorry. Scanf, and then percent LF, and then an ampersand and grade. Now it's fine that I retrieve the grade, but now I got to do something with it. So I'm going to put it in my sum. So I'll say sum is equal to sum plus grade. And up here, I said sum equal to 0. Since I'm summing it, I'm adding, you always want to initialize it to 0. If I'm finding a product, you initialize it to 1. Okay, so each time it gets grade, and then it adds it to my current sum, which is what this is doing. Now the question is, when this gets done running, what is count equal to? I think it'd be equal to 11, which isn't what we want. So like if I did printf %d /n, and then count, and I'm not sure if I really want to input 10 grades, but I will. 3, 4, 5, 4, 5, 6, 7, okay. See how count is now equal to 11? Because the very last pass through here, this will increase count by 1. So if count's 10, 10 plus 1 is 11. Comes up here, compares count, says is 11 less than or equal to 10? And it's not, it's false, so it drops out of the while loop. But taking that into account, I'm not going to use count to figure my average. I could hard code it for now. So average is going to equal to sum divided by count. And then I'll do printf, the average is %.2f /n pool, comma, average. Okay, so if I run this, input this grade, 70, 72, 75, 81, 83, 61, 70, 75, 81. I can have decimals, by the way, since I declared it that way. 81.55. Comes back and tells me my average is 68.14. 68.14. That seems low. I would expect low 70s, but let me see. Type down my scientific calculator here. 70 plus 72 plus 75 plus 81 plus 83 plus 61 plus 70 plus 75 plus 81 plus 81.55. Close parentheses, divide by 10. It is low. Interesting. Oh, by count. I meant divide by 10. Yeah, I actually changed that. Yeah, sure enough. When you divide by 11 is correct. In terms of what we just got, the correct way to do it, though, is to divide by 10. So that would give us the correct answer then. But that's how you can program that average program. Now you probably do it a little bit different. Let's see, counter there. Oh, they hard coded 10. Never mind. Here's Sentinel controlled repetition. Sentinel controlled means the user types in something in the input. And so let me show a Sentinel controlled program. I'm going to do the same program, but I'm going to change it to be Sentinel controlled. So that's all fine. That's all fine. Count is equal to 1. Different ways to do this. I'm going to put an extra if statement in here because I think it's a little easier to understand. And I don't want to control by count anymore. What I want to check to see is if they put in a value that's invalid. So what I'm going to do a printf, and I'll say input grades, and I'll say -1 to end. So then here, I'd say grade is equal to, I'll put some bogus value here initially, 0. Now, while grade is greater than -1, because you could get a 0 on a test. You're not going to get a -1 on a test unless the instructor hates you. But you could get a 0 on a test. So this is checking to see if the grade is greater than -1. If it's equal to -1, then it's not going to do the while loop anymore. So then I'll say input next grade. I'll get the grade like this right here. I'll add it to my sum, and then I'll have count is equal to count plus 1. Now for my count. This time, I'm going to start it at 0. The reason I'm doing that is then when I input a grade in, I'll increase the count by 1. So initially, count 0, so 0 plus 1 is 1. That means I'll have 1 grade. And now the count will work when I figure my average. Now down here, when we do a scanf, if they actually put in a -1 for the grade, I do not want to add it down here. Or do the count equals count plus 1, because -1 means I'm done with the program. So here I'm going to put another if statement. I'm going to say if grade is greater than -1, my curly brace, and I put in do that quite right, but oh well. And sum is average equals sum divided by 10. All that rest side, I believe, is correct. Okay, so let's talk about this. Come down here, it says input grades -1 to end. Comes here, checks to see if grade is greater than -1. It is. I set it to 0. This is a dummy value to begin with. Then comes down here, ask them for the next grade. Let's say they put 80 in. It retrieves 80, puts it into the variable grade. Then it checks to see if grade, which is 80, is greater than -1. It is. 80 is greater than -1, so it comes down here, it adds 80 to my sum, increases the count by 1. And then it's done with the code inside the while loop, so it comes back up here. Now the grade I input was 80, and it checks, is 80 greater than -1? It is. So it'll ask him for the next grade. And so on, until eventually when asked for the next grade, they put in -1 saying I'm done. So at this point, after it does the scanf, grade is equal to -1. It comes down here and checks, is grade greater than -1? It's not, it's equal. So that would be false. And so it drops down here, comes back up to here, does this check. Grade is -1, so it says is -1 greater than -1? It's not, that's false, so it drops out of the while loop. And then comes down to the bottom and calculates my average. Okay. Now if I run this. Okay, so input grades. Looks like I need a line break there. Input next grade, I put in 80. Input next grade, I put in 70, 75, and I keep on doing this until I put -1 in. Okay, so put a -1 now. -1 is our trigger, our flag, to say, okay, we're done. We're done inputting numbers. So then it should find the average of 80, 70, 75, and 60. And let me put that in my calculator here. See what I should get. 80 plus 70 plus 75 plus 60. All of that divided by 4. I should get 71.25. Nowhere close. Let's see what I've done wrong. What if it included -1? Okay, increase count. Oh, 10. Now instead of hard coding 10, I want to put count there. So let me run it again. And I should have put my new lines in there. What numbers did I have? 80, 70, 75, 60. And -1 to end. And 71.25. And that's what my scientific calculator tells me. So there. Okay. Is there any questions on that? That's an example of a sentinel control. Now I'm just showing some examples here. As you're going through the week, if you want to see more problems worked out of the back of the chapter, you just have to let me know. Say, email me, say, hey, can you work these 3 programming problems, just as long as they're not the homework, and I'll work as many as you need to see. So I want you to have the examples you need to be successful at this. Now, if this is your first programming class and you're just struggling, you're going through this, that is a way that most programming classes are for your first one. Do not feel that you're maybe not cut out for it. I always tell this, but I took a basic programming class in Montana. It was a decent one. I struggled in it and so forth, and I took advanced basic up in Montana twice, dropped it twice. Wasn't very good at that. The instructor was teaching on IBM. What we view now as like Windows. And I was programming on Apple, the precursor to Macs. And he couldn't help in any way, and the documentation was horrible. There was no internet back then that I could access. So I had to drop it twice. I didn't want to give up. That's why I took it again, but I just wasn't any kind of documentation. Came down to went to Fort Scott, took another basic programming class. I don't know why, since I already taken one. Um, because it was Windows based, or not Windows, but it was a PC. Windows um, wasn't on those computers then. That shows you how old I am. And then I took a COBOL programming class, which was a waste of time. He just had us type in programs from the book and just compile them, then make one change the entire semester. I got a little bit better at typing. So really, I hadn't taken any real programming class. Entered into my junior year level at Pittsburgh State. Went in my first real programming class. Not one of my programs worked. Every one of them had errors. It just didn't give the right result, and so forth. And I was ready to drop, change majors, go into art or something. I didn't know. Um, I talked to the professor and I said, I'm thinking about dropping the class. And he encouraged me to stick with it, which I'm very glad of. And what you'll find is that each programming class you take, your skills become better and better. I can't tell you how many classes to take, but you need to get that comfort level down. In some students, that may be one class. You take one programming class and you have it. And for another student, you might have to take 5 programming classes, and then you have it. I don't tell people this, so they will sign up for a lot of my classes. I don't care where you take the programming at. You could even go out on your own and learn programming. There's a lot of free resources out there. I think there's a Udemy. I buy their $10 courses whenever I want to learn some new topic. But you need to get that comfort level down so you'll be successful, at your junior year level in programming. Anyway, if you're going through mud in programming, that's normal. It'll come. The more you do it, the better and better you get at it. And do not hesitate to holler at me and ask for more examples. And I haven't put it out there yet, but Thursdays I'm here till I think it's 8:30. Yeah, 8:30. So, if you can get on Zoom sometime, then after my last class on Thursday, then I can walk you through. I won't actually do it. I'll just walk you through and say, well, now what do you see wrong there, and kind of guide you. Anyway, where's PowerPoint? There we go. And they might do it a little bit different. -1 to n. -1 is kind of the standard, unless -1 is an acceptable value. Okay, they do while grade is not equal to -1, which would imply a person could put -3 in. So I don't really like their sentinel control, but it works. Just has a flaw. Well, counter is not equal to 0. Okay, I never took that into account on mine, because they run a program and they don't put any numbers in. They put -1 to begin with. I'll get division by 0. See, like if I run this and I don't input any grades, I just immediately go to -1. See how it came up with this weird result right here? The average is -1 point pound sign. I'm not sure if that's a bracket or J or what that is. That's because when it came down here, count is equal to 0, and it said average is equal to sum. I don't know what sum would have been at that point. Sum might have been 0. And so 0 divided by 0 gave me division by 0, and it gave me bizarre results. So that's not a bad check they put in there. Well, they check if count is greater than 0, then that's when we want to figure our average. See, these are things that I don't think of right off the bat, but as I'm testing, maybe I would discover that. Or maybe the user would call me up and say, your program doesn't work if I don't put any data in. If I just put -1, it does weird things. Well, let's try that now. Okay, I put -1 in. That's no good. It didn't give me an error or bizarre results, but it should have said something. So this is where I put an else statement. else printf no data input /n. Then if I run that, okay, so if I put -1 in now, it says no data input, and that's better. This is what it should have on each one probably. So if I were to change it, because of that, that scrolls up to where you can't see it, and then you're wondering, well, how was it? What was I supposed to do to end it? Okay, so let's see, put that there, or no, I want to /n here for the next line. Input next grade there, and -1 to end. I guess I wouldn't even need this up here, would I? Now that should be a little bit more self-documenting. Input next grade. So 50, 70, 92. Eventually I put -1 to end and do that. Now this would be anything where you just want to keep getting data until there is no more data. So you're asking the person to input sales. So they'll put their sales for each day, and when they're done, they just put -1 in, and maybe it'll give them the total sales. In theory, what you would do is go out there and maybe update a spreadsheet, update a database or something after you put your sales in. Not that we design programs like that anymore, but okay. This just counts the number of passes and fails. Now here's, oops. Here's the assignment operators. And I don't really like these at all, but you can use them if you want. And that's why I left them in here just to present them. I would use this. C is equal to C plus 3 if I want to increase C by 3. Instead of doing that, you can type C plus equals 3. And that does the same thing. Well, there's 1, 2, 3, 4, 5, and I guess if you include the semicolon, 6 characters there. 1, 2, 3, 4, 5. So you've saved one character, doesn't make it run any faster, and I think just makes it a little bit more confusing to read. So I love this format. I'll keep on showing it. But again, there's more about that. You can read it in the book if you're real curious about that. Here's how to do the other shortcuts. D is equal to D minus 4. You get D minus equals 4. Here's the multiplication. E asterisk equals 5. Again, they're there. Now here's the increment and decrement operators. And I'm really not crazy about these either. If you want to use them, that's fine. The idea on it is down here where I did count is equal to count plus 1. Instead of typing it that way, I could simply have typed count plus plus. This does the same thing as count equals count plus 1. Now we're going to find that this notation is actually pretty useful in the for loop. But outside of the for loop, I never really use it. But if you want to, you can. And that does the same thing as adding 1. So it increments it by 1. And you can do a plus plus before the letter, after the letter, and that determines when does it increment it. After that statement gets done running or before, and so forth. You can also use minus minus to decrease by 1. And I got a program here where you can run it, see the results, prints values. Now here's our order of operations so far. So it handles plus plus, minus minus first. Then it does the plus, minus for type, and plus, plus, and minus, minus prefix. So postfix versus prefix. Then these asterisk, divide, and then down here is the actual plus and minus for subtraction or addition and subtraction, not unary. And then your inequality, less than equal to, greater than equal to, equal, not equal, and our conditional, and then our assignment. Now I left these in here. I'm not going to go over these. I'd recommend you read it in the book. It's not bad. Maybe I'll go over it a little bit. It talks about why C has so many issues. This is why people can hack into your program. This gives you an example here. Present an additional program which calculated the sum of two integer values, so integer 1 plus integer 2, and assign it to sum. So very simple statement. But then it says, even a simple statement has a potential problem. Adding the integers could result in a value that's too large to store into an integer variable. Well, what does that mean? Well, you can only put so large of a number in here. So if you got a huge number in integer 1, you got a huge number in integer 2, you add them together, that's going to be a number that's bigger that can go into sum. And this is known as arithmetic overflow, can cause undefined behavior, possibly leaving a system open to attack. They go over here, talk about the integer max and integer min, and give you guidelines on how to program for it, and so forth. And again, I'm not going to go over that. Just kind of talk generally about things to watch out for. Talks about sentinel controlled loops using invalid values to terminate a loop. Is there something I can do as a user where I could cause that loop to terminate, where it leaves your system compromised, where I can potentially do some damage, hack in and so forth. Here's some more secure versions of printf and scanf. They talk about that in the book. And some more of that. Okay, grab a drink here. Is there any questions on the while loop? Well, I'm going to go ahead and stop the recording there. And if you got any questions you want to ask after the recording's done, then I can help you with any problems you might be having or answer any questions. I will put the projects out there for this chapter along with the recording.